Thank you. So our next speaker, I'm very happy to introduce Al Florence. Al's talk is going to be proven management and technical processes and procedures are paramount for project success. And I've gotten to know Al a little bit over the past few weeks, and I guarantee you he is an expert with deep, deep knowledge in this area. So, Al?
Next slide. So I'll be talking about what's required to put together large technical projects successfully. I say technical and management process and procedures, and also very important are adequate budgets and schedules. Next slide. This kind of shows you why they're needed. The top one, 66% of all technical projects end up in partial or total failure. And I would say if you add late on schedule and over budget, it's not on. Is that better? Yeah. Okay. If you add late on the budget and over schedule, you're talking more like maybe 25%. And another thing that happens is that during development, if you catch a problem later in the life cycle, it's going to cost you a lot more than if you caught it earlier in the life cycle. In this case, it goes up to 6%, up to 15%, depending what you find. They also have seen studies that say that if you catch a requirement during testing, it costs you probably more like 25% as opposed to having caught it during the requirements phase. Unfortunately, I don't have time to talk about all these areas, so I'll only talk about requirements, configuration management, next slide, and risk management. Next slide, please. Next slide. Oh, I'm sorry. There's many areas I could have talked about in requirements engineering, but I chose to talk about critical attributes that requirements need to meet. First of all, they have to be complete. They have to define the entire system. Ambiguous requirements are very difficult to implement. The designer may not know what the systems engineer meant with this requirement and may go off and implement the wrong thing. And then later in the life cycle, you have problems. May go back to the systems engineer, try to get clarification, and maybe voices a clarification, understands it, implements it. During testing, they don't understand it, or during implementation. So the best thing to do is avoid ambiguous requirements. In my poster session, I have a list of words that you should avoid that are ambiguous. Each requirement has got to state exactly what the system needs to meet. And they have to be consistent. They can't be in conflict with each other. You have to be able to develop and test each and every requirement against its design. And things change, especially on a new project or new systems like the Hyperloop. Things are going to change. So some requirements are going to be more apt to change than others, so you have to take that into consideration. You have to be able to trace each and every requirement from its source to its specification, to its design, to its implementation, and to its test. And by lateral both directions, they use a traceability matrix to do that. Some requirements are going to be more important than others, so you have to indicate that, because they would have more critical aspects as to the design and the implementation. Things are going to change. Things change. It's a changing world. Hyperloop is going to have a lot of changes that's been developed. So you have to take that into consideration when you develop requirements. Rank them for stability. Next. Let's talk about configuration management. It's a discipline of applying technical and administrative direction and surveillance to identifying, documenting the physical function and performance characteristics of items. You need, when you decide to control something, you have to baseline that, whatever it is. Baseline implies that you can't change it without a formal baseline control session. So it's kind of set. Once you baseline it, you have to control changes. You have to get approval to change it. You have to keep stakeholders and engineers aware of your characteristics or the status of them, and you can do that with the configuration management audits. Well, how do you accomplish this? Well, you start with the planning. You always plan. You want to plan almost anything you do, especially on those important areas. And your plan should have configuration identification. This is very important to identify those areas you want to control. You can't control everything and anything. So you have to pick the ones that are most important to the program. Cost, schedule, performance, and that kind of thing. And you have to keep status of and make people aware of where you are in this configuration management activity by having status counting and management audits. Okay, let's talk about risk management. It's going to be a lot of risks. A lot of risks. New technical projects, except large ones that have never been done before, are very, very risky. In fact, risks are all around us every day. Risk, risk, risk. So you have to have a good risk management program. Risk response. You develop options and actions to enhance opportunities and reduce threats from project objectives. You do this with mitigation of risks and contingencies for issues. A risk becomes an issue when it's materializes, when it becomes a risk. And you can also accept the consequence of the risk or the mitigate or the issue. There may be nothing you can do about it, or it may be insignificant. Next slide. How do you do this? Well, you certainly have to have a plan. You always plan all important things. You have to have a plan at the beginning of the project. And when you encounter a risk, you want to create some plans to try to mitigate that risk. And you continuously try to identify risks as they're happening. And when you do encounter one, you want to make sure you do a root cause analysis. This is very important. You have to find the reason that that there's a risk, a root cause. And once you find the root cause, you can try to correct the root cause and maybe mitigate the risk. The problem I've encountered more than once is programs don't do a very good job of root cause analysis. Some don't do it at all, others do it very badly, some do it very well. Problem with not doing a root cause analysis is, first of all, if you don't find one, there's no risk. So it's over. But if you don't do it and there is a risk, how do you fix it? You don't know how. Now, I've been on programs where they don't do a very good job of risk root cause analysis, and they wind up with risks that are non-risks, sometimes hundreds of non-risks. And they're not, it's costly and expensive to do that. You spin your wheels. You're quixotic chasing windmills. You don't want to do that. So you have risk response, which you try to mitigate the risk or the issue from happening. And you continuously try to monitor and control risks as you find them. Getting close to the end here. How are we doing? Okay. Over the years, I've been around a while, and I worked at several aerospace corporations at a think tank. And I have developed process and procedures for just about all these areas that I showed on the first two slides. And I have implemented it very effectively on many programs. And I have given conference presentations, at least 200 conference presentations and teaching lessons at my different companies on all these areas. So here are some areas you can look at and see some of my work. Some system failures. I don't know if you all are aware of some of these. The Denver Airport baggage failure. That when they first built the Denver Airport, they decided to automate the baggage system. And they got a French contractor, I believe, to do that. And apparently they didn't have very good requirements, very good budget, or very good systems engineering. And the thing wouldn't work. Bags were flying off the carts. Took them a year with problems, and it was costing them at one time $1 million a day to keep that thing up and running. The Denver A failure, A line, when they built the trains to go from downtown to the airport, the closing gates would not close automatically. The software was broken. And they had guards there closing them, opening and closing them for a year. The Mars thing. Feel sorry for my poor wife. She worked on this project. And what happened here, there was a multi-billion-dollar project, a Mars mission, and the thing got lost in space. And the reason for that is because they were cheap. They didn't put the right kind of budget into it. We all know about the Affordable Care Act. It took forever for it to get online. I don't know how many months and months. They got a Canadian company to build the system. I don't know if that's good or bad, but apparently something went wrong. Next slide. What I'm saying here is that not all it's a system of systems. There are going to be small systems, bigger systems, but they're all going to be integrated to make a big system, the Hyperloop. And some of the systems will require some level of process more so than others. So you have to tailor the process accordingly to the technology and the size of the particular system that you're building to make a big system. I think I'm done. Any questions, any comments? Okay. Yeah.
So one of the biggest problems Hyperloop's going to face, I see, is getting all the competitive companies to be able to standardize structures so that regulators around the world accept a single Hyperloop. How do you manage?
Well, that's...
Repeat the question.
Yeah, he's saying that to build this thing, you're going to have developers throughout the world really building different systems to integrate into one. So they have to have an overall integration plan that all the developers would be involved in building that plan, making sure that each one of them has the right process and procedures to develop their portion of it. And the most important is integration, integrating them together. It's not an easy task. Yes?
Thank you. And just as a ballpark estimate, how much of the Hyperloop budget would you devote to risk management, requirements engineering, project management?
I would say 0. And I'll tell you why. Oh, I'm sorry. How much of the budget would you devote to developing the process and procedures for the Hyperloop? And my answer is 0. And let me say why I say 0. Because if you don't implement them at all, you're going to have cost overruns, and you have schedule overruns, and it's going to cost you way more than if you just spent the time up front to develop these processes and procedures, train people on them, and implement them. You're going to save money. And you have to have them in place before you start the project. Oh, yeah, somebody has to pay for everything. I'm sorry? Initially, I don't know. You're going to have different pockets, and each pocket has to build their own depending. Some will need more process, more procedures than others. But somebody's got to make sure that they're being integrated. So each pocket would cost 10, the other one 100, and so forth, and you add it all up. I don't know what the number is, but it's big, but in the overall thing, it's going to be less than not doing it at all for the entire project. That's my opinion. I've seen that happen. Anybody? Yes? For risk? Yes. Do I have a tool for quantifying risk in the model? Attend my poster presentation. I have, I think, 16 view graphs on that go into more detail on risk management. And you may get your answer there. If not, we can talk about it. And yes?
Yeah, so I really liked your slide on risk. I think I could take the normal infrastructure project, road, bridge, tunnel, airport, and square it. So there's going to be in every aspect of this. So the issue is going to be how do you give some comfort to investors. You're going to need big investors. And there's large pools of money like insurance companies, mutual funds, hedge funds, sovereign wealth funds. And they normally, require specific legal and financial arrangements to invest in this. They don't invest directly. They do it through, say, a special purpose vehicle or project finance. And I'm wondering what, in your vast experience in infrastructure delivery, how do you see the financial arrangements involved?
I worked a lot of proposals on very big projects. I did multi-billion dollar projects. And before you go out and solicit contractors, you put together your plan for accepting bids. And in that plan, that's where you describe the kinds of things you need to do from a process perspective. And that's important. If you don't do that, you're going to have problems. Anybody else?
Sorry, we should move on. But that
Sure.
was great. If I ever get to taking a project management, the PMP certification, I will talk to you first and learn more. But I know that you usually do this in about a full day.
Oh, no. I have done these on a full week on just one topic alone. Thank you.